Every day, new discoveries are unlocking the mysterious, the mind-blowing, the deadly secrets of a place we call the universe. The destruction of planet Earth. The idea has inspired endless prophecies, predictions, and science fiction stories.
One can imagine all kinds of exciting scenarios.
Instant vaporization.
Extreme spaghettification.
Antimatter devastation.
Now, leading experts in the fields of astronomy and astrophysics devise their own plots to destroy the Earth.
You would have buildings melting.
Matter would turn into goo.
Everything that's held together by gravity would disintegrate.
It's an explosive way to uncover the extreme science of our planet and the universe. Get set for 10 visions of terrestrial termination, 10 ways to destroy the Earth.
Don't try this at home.
Survival. It's a game our planet plays every day against an aggressive universe. But for 4.5 billion years, the sides have been evenly matched. So the game goes on.
There are all kinds of things out there that could kill us, but none of them have managed it.
Some threats, like hyper-intense gamma-ray bursts from distant galaxies, miss us completely. Other dangers never make it through our invisible barriers. Earth's magnetic field keeps out dangerous charged particles. The ozone layer filters ultraviolet radiation. But even though the cosmos can't figure out how to destroy the Earth, some top scientists have their own ideas, like Dr. Bruce Betts, an expert on the risks Earth faces from asteroids and other space debris.
A favorite way to destroy the Earth in my more maniacal moments, I'd probably go with my roots and slam a nice-sized object into the Earth.
And so our countdown to catastrophe commences with number 10, Smackdown from Space.
Slamming things together. It's the monster truck rally of Earth destruction.
But Betts knows that smashing the Earth isn't so easy.
Nasty impacts cause destruction, but they're not very good at destroying the entire Earth, even though they may wipe out significant amounts of life, like 65 million years ago with the dinosaurs and 70% of the species on Earth.
The problem? The dino-dooming asteroid just didn't have enough mass to completely destroy the planet. The asteroid was a little bigger than Mount Everest, which sounds impressive until you step back about 200 miles.
If we had a globe that was actually to scale, you wouldn't be able to feel the Himalayas with the tips of your fingers. They look huge to us, but compared to the actual size of the Earth, they're like anthills.
We need something at least half the size of the Earth and 1/10 as massive, heading for us at 30 miles a second. Let's try Mars.
You could change Mars' orbit, throw it inwards, and lead to the doomsday impact. Even as they approach each other, their own gravities are going to pull each other together in a final death cling.
As the red planet fills Earth's skies, enormous tsunamis obliterate islands and coastal cities. Then, things get very bad.
If you live on the side of the planet where Mars hits, instant vaporization.
The side that doesn't get hit is struck by continent-cracking earthquakes. The heat from the impact turns every forest into an inferno. Molten mountains of Earth and Mars, thrown into space, rain back down in an apocalyptic shower of destruction. An hour after impact, whatever lived on the surface of the Earth is dead. But Earth is so big, 6 billion trillion tons of rock and metal, that even a direct hit from Mars would leave the planet itself damaged, but essentially intact. Really destroying the Earth requires something bigger hitting us, like our sister planet, Venus.
You're talking a very similar diameter, and you're talking over 80% of the mass of Earth. So if Venus comes at us and hits the Earth, we're toast.
Both worlds shatter. Huge fragments shoot into space. But planetary rubble will also fall back and coalesce into an Earth-Venus amalgam, bigger than either original planet and as dead as the Moon. Definitely a good way to destroy the Earth. But how likely is it? 4.5 billion years ago, something as big as Mars did hit us. The early molten Earth was still cooling when a smaller planet struck us hard.
It's like a ball hitting in the sand, knocking a bunch of particles.
The object blew off part of the Earth's crust and formed a disk of debris around the Earth. From that debris, the Moon formed quite shortly thereafter.
But while planetary impacts are possible, Venus is more than 23 million miles from Earth, and Mars is at least 35 million miles away. So how would you get them from there to here?
Planets are normally in very stable orbits. But what if something happened that threw a planet completely out of its normal orbit?
Mercury, the innermost planet to the Sun, has a rather elliptical orbit. It's subject to various gravitational perturbations by other planets. Such changes in Mercury's orbit can also indirectly affect the orbits of other planets, and in particular, Mars could take on a trajectory that could someday intersect the orbit of the Earth.
Some say the odds of a real-life Mars-Earth collision are 1% over a period of 4 billion years. Not likely enough to worry about, but not impossible.
Imagine that there's a single fly in this entire stadium, and it's flying from goalpost to goalpost. If I just go like this with my hand, what are the chances that I'm going to catch that fly? You wouldn't say it's 0, because there's no real reason why it can't happen, but you would say it's extremely small.
Planetary impact is one way to destroy the Earth, but we're just getting started.
Now, if you want to have a longer, slower, more painful process, then perhaps you end up having the Earth's orbit modified somehow so that it ends up moving outwards from the Sun.
Welcome to the number 9 way to destroy the Earth, the Big Freeze. Under normal circumstances, our elliptical orbit takes us 3 million miles farther from the Sun in July than in January. The reason it's warm in July north of the equator is because that's when the northern hemisphere tilts towards the Sun. If we spun the Earth away from the Sun at 3 million miles a year, the journey wouldn't be instantly fatal.
If we move a little bit, we can deal with it. We wear more jackets. If we keep moving farther out, then things start to get uglier.
At almost 200 million miles from the Sun, the light is only about 1/3 as bright. This would kill off most crops.
The whole food chain would be broken down if the Earth were to go zooming away from the Sun.
And if you really play this game, If you get out at the orbit of Neptune, say, you might start freezing out most of our atmosphere.
A nice day is 350 degrees below zero. Nothing survives on the icy surface. The oceans are frozen graveyards. But 2.5 miles below the surface, the water is still liquid, thanks to the heat from undersea volcanoes. Sulfur hydroxide from these hydrothermal vents will continue to feed large tube worms and other exotic forms of chemosynthetic life. Continuing heat from the Earth's core may also help humanity survive in cities below the surface.
Mankind is a very resilient species, and if the Earth were spiraling out on this freezing death orbit, then I think it's very likely that we would find ways to dig in underground. You could use the geothermal energy to convert some of the frozen materials back into the liquids and turn some of the water into oxygen and gases that you need.
Subterranean farms might support a few million people. It might not be pretty, but the planet, and at least a fraction of its people, could survive. But that's not the case with the number 8 way to destroy the Earth, zooming toward the sun, and the Big Burn. Imagine getting 3 million miles closer to the sun every year. The term global warming doesn't even begin to describe the situation. Liquefying polar ice caps? That's just the first few years. The sea level may rise 200 feet, but all that water is about to turn to steam.
If you move to where Venus is, a third of the way in towards the sun, you're going to get to the point where you start losing the liquid water and it's going to be going to vapor. You end up having a carbon dioxide atmosphere, and you have a massive greenhouse effect, and you end up with a hotter surface than you even would if you had no atmosphere.
From Alaska to Australia, the average temperature is 900 degrees Fahrenheit. All complex life is dead, and the planet itself is headed for a final plunge into the nuclear heart of the sun. Astronomers and astrophysicists have come up with 10 ways to destroy the Earth. And after being smashed and slowly frozen, the planet's on a death spiral into the sun in the number 8 way to destroy the Earth, the Big Burn. Dead, barren, and choked with greenhouse gases, the Earth is now just a few million miles away from the star that once gave it life.
Eventually, all that we would have left would probably just be a big ball of burnt, charred cinder that's moving closer and closer to the sun. And as you got really close to the sun, even that would be vaporized away.
The vapor is going to be moved away by effects like the solar wind. You're going to strip it off. And I suppose for some brief period, it would look like a comet.
At last, only the core remains. A 4,300-mile wide ball of iron, nickel, and radioactive metals, as hot as the sun's surface, but 2 million times smaller.
And that's what would end up actually colliding with the sun. And the sun probably wouldn't even hiccup or cough.
To change our orbit so fatally would probably take nothing less than a runaway sun from many light years away, disrupting the gravity of the entire solar system.
The chances that a star will come by sufficiently close and do that are very, very small. But it's not inconceivable that sometime in the next few billion years that will happen.
Disrupting the Earth's solar orbit means a long, drawn-out death. But stopping its rotation would be a very violent end. That's the number 7 way to destroy the Earth, stopping the spin.
If you stop the Earth, but not the objects that are standing around on the Earth, those objects would keep on going. So, for example, you would get thrown at a wall at a really high speed.
The Earth is moving about 1,000 miles per hour. And if you suddenly stopped, the atmosphere wouldn't necessarily stop with it. And so instantly you would have 1,000-mile-an-hour wind everywhere on the planet at once.
At the exact same time, vast amounts of built-up rotational friction would be released as tremendous heat.
You would have rocks melting, you would have buildings melting.
Soon, the Earth would be a dead world orbiting the sun.
Our day-night cycle would be dictated by the year, the time it takes for the Earth to orbit the sun. And a day would be half a year long, and a night would be half a year long.
One side would absorb the sun's heat for 6 months at a time, while the dark side would lose heat. There would be 2 seasons, bad and worse.
This difference between the hot side and the cold side is going to end up creating massive wind jets streaming from one side to another, massive convection currents.
From pole to pole, the shadow area between the light and dark sides would be filled with massive cyclones. As the Earth moves around the sun, the 2 12,000-mile bands of extreme weather would churn across the globe.
So every 6 months, every spot on the Earth will have a cyclone season.
Basically, big old hanging mess.
It's a mess that's hard to engineer in reality.
You might imagine it happening if something were to collide with the Earth in just the right way, in such a way that balances the tendency of the Earth to rotate and so on. That collision would have so much energy that the stopping of the Earth wouldn't be our main concern.
As awful as stopping the Earth's rotation might be, it at least leaves our planet as a member of the solar system. But there are dangerous forces out in space that can remove every physical trace of Earth. Like the ultra-dense remnants of collapsed stars called black holes. A black hole's greatest area of danger is its event horizon, a gravitational point of no return.
If something is crossing it, there is no way that it can go back out. It sucks the space-time around it towards itself, so that matter just present in that space-time also gets sucked into the black hole.
A typical stellar mass black hole weighs in at around 5 to 10 times the mass of the sun. Putting something like that next to the Earth would certainly destroy the planet. But let's make it more interesting.
What if the Earth were between 2 black holes? With 2 black holes, you'd have double the fun.
And that's the number 6 way to destroy the Earth, torn between 2 black holes.
One of the black holes would pull on the near side of the Earth more than on the center, stretching it out. It would also pull on the center more than on the far side, stretching it out as well. The other oppositely directed black hole would do the same thing.
The black holes wrench the Earth's crust, lifting tectonic plates and distorting the semi-solid lithosphere below. Molten magma triggers apocalyptic volcanic eruptions, and the black holes keep most of the ash and dust from falling back to Earth. In the oceans, huge tides rise and never fall. As parts of the planet fall into the black holes, matter and gases turn into deadly energy.
The stuff falling into the black hole will be bursting out X-rays. And these X-rays would flood the planet and kill everybody pretty quickly.
Meanwhile, Earth is being stretched to its breaking point.
They would be stretching the Earth in opposite directions, and it would be like that famous business of tying horses to the four limbs of someone, tearing them apart.
Will the stretched out planet forever link the black holes? Or will it snap in half? On the list of 10 ways to destroy the Earth, number 6 finds the planet in very bad shape, torn between two black holes. It's a gravitational tug of war, with Earth as a rope that can't withstand the strain.
You would have a case of extreme spaghettification. Earth would be pulled in each direction, stretched in two directions toward both black holes, and eventually ripped apart. And then those pieces would get ripped apart. And those pieces would get ripped apart.
After the last spaghetti strands of Earth are violently sucked into the event horizons, the two black holes will be bookends on the empty shelf where Earth once stood. It's comforting to know that the odds of being stretched between two black holes are slim to none. But physicist and science fiction author Travis Taylor, who's written several books on real and imaginary threats from outer space, has another idea involving destructive black holes.
If I wanted to destroy the Earth, my favorite is that we trap a black hole in the core and eat the Earth away. So I would like to be on a spaceship way away to watch it collapse on itself.
And that's the number 5 way to destroy the Earth: devoured from within. A stellar mass black hole would do the job quickly. But there are other intriguing possibilities.
So what else can we think of? Well, maybe the black hole is the size of my earring.
A black hole that size would have the same mass as the Earth itself. Let's take the miniature black hole and drop it through the North Pole. Assume the speed and angle are just right to have it end up rotating in the center of the Earth. Right away, we'd know something was very wrong.
If you have somehow managed to get an Earth mass black hole at the center of the Earth, then on the surface of the Earth, we would suddenly feel twice the effect of gravity.
All of a sudden, a ball would drop much faster.
All of us are going to start hunching down.
While all living things struggle helplessly, the miniature black hole is sucking in matter. The more it eats, the closer Earth comes to doomsday.
As it's pulling the material in, all the material above it is going to be collapsing. So we will be having enormously massive earthquakes going on, shifts in the crust.
There'd be new volcanoes because new places where the magma can pop out or would appear due to this black hole. So one can imagine all kinds of exciting scenarios.
After months of increasing cataclysms, the finale will take less than an hour.
The Earth will start to collapse on itself, and then that part would be eaten by the black hole too.
Perhaps the Himalayas will be the last place on Earth to survive before they too fall through the event horizon to disappear forever.
If you were up in a spaceship and watching it, it would probably look like you took an eggshell and somehow crushed it from the inside out. If you could attach a string at every point to the inside of the eggshell and yank it all at once, you would see it just immediately collapse on itself.
All that would remain is the black hole. The mass of the Earth would just exist now inside that black hole.
No one has ever found an Earth mass black hole. Normal black holes only form from the supernova death of stars that were at least 10 times more massive than the sun. But black holes with 1,000,000 times less mass might be out in the universe. According to one hypothesis, shortly after the Big Bang, there was so much matter packed so densely together that millions of miniature so-called primordial black holes could have been formed without the need of dying stars.
We don't know of the existence of such black holes, but they could exist and they could devour the Earth.
Probably we don't want to go and find one of these just to try it out.
But could we create a mini black hole right here on Earth? Perhaps with a particle accelerator like the Large Hadron Collider in Europe? That's what Justin L. from Salt Lake City, Utah wanted to ask the universe. So he texted us. Can a super collider cause a black hole?
Justin, great question. A lot of physicists would like to know whether the Large Hadron Collider will produce mini black holes. In principle, it can if it compresses a lot of material into a sufficiently small volume. Then it'll produce a black hole. But don't worry, such black holes will quickly evaporate and they won't devour the Earth.
In space, the destructive power of black holes comes from their irresistible gravity. But a lack of gravity could be even more dangerous for the Earth. That's what intrigues astronomer Alex Filipenko, whose groundbreaking studies of dark energy and the acceleration of the universe have inspired his own vision of doom.
Perhaps my favorite way to destroy the Earth is through a disruption of what we call gravity.
And that's the number 4 way to destroy the Earth. Turn off the gravity. Everything we do depends on a balanced relationship with gravity. But what if gravity decided to end the relationship? Without gravity, what goes up will never come down. Airplanes will never land. Trees are rooted to the ground until the ground comes apart. And all that is just a warm-up for the real disaster to come. Earth itself would begin to break apart, piece by piece. It seems impossible. But could gravity really be switched off? Incredibly, the answer is possibly.
In the future, gravity may cease to exist.
Of the 10 ways to destroy the Earth cooked up by astronomers and astrophysicists, one of the most incredible is number 4, turn off the gravity. Today, gravity is one of 4 basic forces. Along with electromagnetism, the strong nuclear force that holds atomic nuclei together, and the weak nuclear force that's the source of radioactivity. But at the time of the Big Bang, instead of 4 fundamental forces, there may have only been 2.
When the universe was a tiny fraction of a second old, the strong nuclear force was unified with what's called the electroweak force, an amalgam of electromagnetism and the weak nuclear force.
That united superforce may have created a super energy that could have caused an almost instantaneous expansion of the universe, called inflation.
It became monstrously big in a very short amount of time.
But in a minuscule fraction of a second after the Big Bang, inflation stopped as the forces broke up.
The strong nuclear force split apart from the electroweak force, becoming 2 different manifestations of this previously unified force.
If a seemingly unified force could split in 2, can it happen again with gravity? This terrifying possibility can be represented with a simple coin. A quarter has two faces, but if you impart energy to the coin by spinning it, the two faces seem to merge.
You see neither heads nor tails distinctly. Now, eventually, that quarter loses energy and it lands either heads or tails. Two distinct outcomes, neither of which look like the spherically symmetric spinning quarter. In the same way, the symmetric gravity right now could someday split into two different aspects. Each of these two new forces would behave in a way distinct from the current behavior of gravity. Everything that's held together by gravity would disintegrate. And that would spell doom for us on Earth.
Human bodies would remain intact because they're held together by electromagnetic forces, not gravity. But everybody on Earth would fly up to suffocate in space, while the Earth itself would come unbound, no longer held together by gravity. Jupiter and the other gas giants would dissipate. The Sun, whose gravity once spun the planets like balls on strings, would fly to pieces.
Most of the sun is all big hot ball of gas anyway, and it's held there by its own gravity. So what you would probably see is a star drift away rather quickly.
The sun wouldn't be held together, the galaxy wouldn't be held together, everything would be drifting apart.
The Earth would be just random particles in a small corner of a universe of cosmic dust.
That would be a pretty amazing ending.
Of course, there is another way to take the Earth apart. Blow it up. Easy? Of course not. But there is a way.
Create an antimatter devastation bomb of some sort.
That's the number 3 way to destroy the Earth. Antimatter annihilation. And it's the first choice of astrophysicist Clifford Johnson.
The antimatter idea just has a certain beauty to it. It's just the sheer terrible beauty of a really dramatic explosion from the inside.
Antimatter is just like matter, only the opposite. And matter and antimatter destroy each other in a blaze of glory.
So basically, this is Einstein's equals mc squared in action. You can take this matter and antimatter and combine it together and release pure energy.
Just 1 pound of antimatter, annihilating 1 pound of matter, would pack 44 megatons of explosive punch, as much force as a thermonuclear bomb. But destroying the Earth would take a lot more. According to some estimates, you'd need at least 100 trillion tons of antimatter.
So thinking of the size of the stadium, we would have to fill millions of stadiums with antimatter before it could interact with the matter on Earth to actually release enough energy to unbind it.
But if you really want to try, there's an antimatter factory just 93 million miles away. When enough magnetic energy builds up in the nuclear furnace of the sun, it's released in an explosive solar flare. A big flare can generate as much as 2 pounds of antimatter. Contact with matter destroys the antimatter almost instantaneously, but there are ways of containing it.
You can suspend it without touching it by using various kinds of electric and magnetic fields. So you can keep a quantity of antimatter suspended indefinitely.
So all you have to do is collect and store antimatter from around 100 quadrillion solar flares. Once you've got your 100 trillion tons of antimatter, just transport it to Earth and turn off the electromagnetic field so it can come in contact with normal matter.
Maybe put it at the center of the Earth somehow, and then let it do its thing. It'll explode outward and simply rip everything apart.
But while an antimatter explosion would be instantaneous, collecting all that antimatter would take tens of billions of years.
We only have so many solar flares a year. It would take many, many, many years to capture and store enough antimatter to really create a very appreciable sized bomb.
Physicists know that antimatter isn't the only type of particle that could liquidate the planet. The number 2 way to destroy the Earth is a case of destruction through transformation, transformed by strange matter. This is big trouble that starts at a tiny level, smaller than protons and neutrons, in the weird world of quarks. Particles with names like up, down, and strange.
Try not to get hung up too much on the semantics of what a quark is. You might want to say it's a subatomic particle, the thing that makes up the other things.
Some physicists theorize that an equal number of up, down, and strange quarks would make up a strangelet, a particle of something called strange matter. What makes it so strange is that it might change the physical nature of whatever it touches, like ice cooling the water around it, only far more extreme.
They like to turn other things into strange things. They like it all to be strange.
Imagine everything on Earth and the Earth itself turning to inorganic mush, all because of a subatomic strangelet. Fortunately, there aren't any strangelets on Earth. But inside the collapsed suns called neutron stars, it might be possible for the immense gravity to press together up, down, and strange quarks into strange matter.
We are getting very close to the answer. We might know in the next few years.
So if you did find a microscopic lump of strange matter in a neutron star, somehow got it back to Earth and dropped it, say on the top of the Empire State Building, what would happen? A, nothing, or B,
All these strange quarks could change the state of matter here on Earth.
a chain reaction has begun. The strangelets are reacting with ordinary matter. The Earth is changing. But into what? On the list of 10 ways to destroy the Earth, number 2 is perhaps the strangest of all. Transformed by strange matter.
If you wanted to convert the entire planet into a big bunch of strange quarks, all you would need to do is put a few strange quarks here and there, then the Earth would start turning itself strange. Even more strange than it is.
Strange matter, a lump of quark material called strangelets, has been let loose on Earth. And an astonishing event happens. The first thing it touches turns to strange matter. Then the next thing.
Pretty soon, you would be a strange version of yourself.
Even when we look at subatomic levels, just at the nucleus, there is a well-defined structure. We can tell apart protons and neutrons, etc. But if you lost that structure, then matter would lose the shape that we know of.
The unique orbits and numbers of particles that make up the individual elements now form an undifferentiated mass. Everything becomes the same strange matter, from atomic nuclei to monuments and mountains. And whatever is alive dies.
And once it starts, this transition would be fairly rapid. It would be like dissolving something into one huge glob of matter. It would turn into just this goo, this soup of quarks.
You could end up converting the entire Earth into one big piece of strange matter.
Primordial black holes, the end of gravity, antimatter and strange matter. Does theoretical physics have an even more bizarre way to destroy the Earth? Yes. In fact, astrophysicist Ferial Ozel is ready to obliterate the Earth, along with the entire fabric of reality.
I think my favorite way of blowing up the Earth would have to be some kind of huge phase transition in the universe. This would just take us into another state.
It's the #1 way to destroy the Earth, when parallel worlds collide. It starts with another science fiction staple that many physicists now take seriously: the existence of other universes.
It's possible that there are Earths in other universes.
Think of our universe as a two-dimensional sheet which exists here, and moving around in the sheet is like moving around in our 3 spatial dimensions. But then you can move in this other direction, which is sort of off the sheet. And there's another sheet there, and that would be a different universe. Our universe would be just like that one, perhaps, or maybe slightly different. But it's very important to realize that we shouldn't have these two things collide into each other.
Imagine that our universe is a piece of paper, like this. Then a nearby universe would be this piece of paper. Now, if the 2 pieces of paper were to collide, you could hear that energy. Now imagine 2 sheets of paper the size of a universe colliding. How much energy would be imparted at a collision like that?
If we somehow did make contact with a parallel universe, it could be the last thing we'd ever know.
It would not just destroy planets, it would destroy solar systems, galaxies, clusters of galaxies. It would destroy everything.
It would be the end of this current universe.
But is it possible that the end of everything is the beginning of everything else? If one Big Bang created our universe, then another Big Bang could start the whole thing over again.
It might create another universe.
And maybe this most incredible of doomsday scenarios is the only one that's already happened.
The Big Bang came from the collision of such a pair of universes, perhaps. So maybe it's going to happen again.
And if it does, then after about 10 billion years,
Maybe there would be another Earth in another universe.
we've seen the Earth destroyed by sudden impact, bitter cold, and vaporizing heat. It's been stopped in its rotation, transformed by strange matter, spaghettified and swallowed by black holes, disintegrated and blown up. At least in theory. In reality, the odds are that the world will keep spinning for billions of years. But there is so much in the universe we can neither know nor predict.
A whole new Earth in a whole new universe. That could be a totally different place.